All right, hello everybody. My name is Martin Flores, and today I'm going to be going over authentication in iRODS 4.3, investigating OAuth2 and OpenID Connect. So, in this presentation, I'm going to be going over the current state of authentication in iRODS, as well as going over an overview of OAuth 2.0 and OpenID Connect, particularly how they work together. I'm also going to be going over the OAuth 2.0 flows, as well as the reasons for picking which particular flow to implement for the demo. And from there, I'm going to go over the demo setup as well as the demo itself. Additionally, going over any potential issues we have while highlighting configurations that are needed to run the demo. From there, I'll talk about some future considerations, some things that we need to look out for in the future if we wish to further develop OAuth and HTTP API. So, without further ado, let's go into the current state of authentication in iRODS as it stands, as well as we're going to touch a bit about how the HTTP API brings some nice opportunities for change. So authentication in iRODS is all plugin based. So we have the simplest version, which is native authentication, just a simple username and password. We also historically supported PAM, GSI, and Kerberos plugins, but going forward, we're planning on only supporting PAM, as it should be able to cover all these other bases as well. It's a lot more flexible in that regard. However, in the plugins, in the PAM plugin specifically, OAuth is still a bit awkward to use. Largely, this is because the iRODS server itself doesn't support the HTTP natively. As a result, it's a bit awkward to use in that regard. Additionally, the flows are a bit awkward in that you might jump from a terminal to a browser and back to a terminal. We hope to improve the overall flow in the actual HTTP API, as you'll see shortly. So, moving on to the HTTP API, aside from the benefit of it being easy to use, relatively easy to use in any language, as long as you can make HTTP queries, which most languages, if not all, support. It also brings an opportunity for improved OAuth integration. This is largely because the HTTP API, as it says in its name, does natively support HTTP, which OAuth is basically running on. It's powered by that protocol. So it should be much more natural to actually work with OAuth, as well as the HTTP API will allow us to possibly support multiple grant types compared to the PAM authentication, how it is implemented in PAM. Okay, so moving on to an overview of OAuth 2.0 and OpenID Connect. We're briefly going to talk over some high-level concepts of both OAuth 2 and OpenID Connect, as well as briefly mention how they work together. So, OAuth 2.0 is largely focused on effectively limiting client access to an HTTP service. This is at the choice of resource owner and user. It allows for finer and revocable permissions to resource owner data and avoid sharing password credentials, which was a pretty big thing and still is pretty important. OAuth 2.0 is largely authorization focused. So if you were to look at the little ASCII diagram at the bottom right corner, you would see that it's actually effectively all of the flow is just to access a protected resource at the very bottom and the resource server. So if you were to summarize OAuth 2.0, it's largely authorization focused in that regard. On to OpenID Connect. OpenID Connect effectively provides an identity layer and allows clients to get some basic information about the end user, which can then be used to authenticate the user. Once again, this OpenID Connect is largely authentication focused. And if you were to, again, compare the diagrams, you can see that this diagram is largely just about extracting information about the end users. That way the RP or the lying party can then use that information to effectively authorize the user for the application. So briefly going over how they work together. Effectively, OpenID Connect is a layer on top of OAuth 2.0. To simplify it further, you could think of them as complementing pairs. OpenID Connect is focused on authentication, whereas OAuth is focused on authorization. Okay. So with that, we're going to go over into OAuth 2.0 flows. We're going to briefly touch on why we chose to go with a certain flow for the demo, as well as why we chose to go ahead and pass on other flows. So there are 4 flows that OAuth 2.0 specifies explicitly. That is the authorization code grant, the implicit grant, the resource owner password credentials grant, as well as the client credentials grant. The particular flow that we use for the demo will be the resource owner password credentials grant, and you'll see why we chose that one shortly. So lightly touching on the authorization code grant, this grant is particularly used for confidential clients. You can see that a part of the flow, once an authorization code is generated, goes through the client. This is because the client is effectively has a secure channel to the authorization server. Why we chose to not go with this particular flow for the demo is because there would be there had to be some more implementation details in communicating with the user agent from the client, as well as actually implementing a confidential client, which would be a bit more complex than a demo may need. Additionally, there's the implicit grant. This one is particularly optimized for public clients. Typically, they have a well-known redirection URI, and this type of grant, the client is typically implemented in the browser. So why we chose to not go with this grant, again, is a bit more complex than another grant that we chose. It requires communication with the user agent, as well as this is more a browser-based flow, which for demo purposes, it'll be a bit awkward to implement such a thing. So onto the resource owner password credential grant. This particular grant does require a high degree of trust between the client and resource owner. Reason for this is you are providing the resource owner credentials directly to the client, which then forwards it to the authorization server. So you do need to be careful with how you manage the actual credentials there. And this is ideally used when either alternative flows are unavailable or you're migrating from an existing authentication system, which takes username and password, over towards an OAuth or OpenID Connect authentication scheme. So yeah, we chose this particular grant because it was relatively simple to implement while still requiring a degree of interaction between the client and the resource owner. And the final grant is a client credentials grant. This particular grant is only used with confidential clients, and it's also typically used in prearranged agreements, typically where the client, on their own volition or on their own, they wish to access information from the authorization server. For our particular demo, we wanted to have a user agent or an end user to actually interact with the client. So this flow or grant would not be suited for this particular case. Right. So onto the demo. In the demo, I'm going to go ahead and go over some configurations that are needed to actually make sure everything's running just fine. Additionally, I'm going to go over the demo itself, walk you through several steps, just so you know how the overall flow works. And additionally, I'm going to go over some issues encountered while developing this entire demo. Okay. So for the setup, we are using a specific build of iRODS that has an additional PR to effectively have some additional connection management, some general improvements like that. Additionally, we have the HTTP API with endpoints PR. For the HTTP API, we're particularly going to be going over some additional configs that are specific for OpenID Connect. And we also are using an OpenID provider. In our particular case, we're using Keycloak, but the specific provider doesn't really matter. Any OpenID provider will be perfectly valid. There are some additional configurations that we need for that, just so the demo, so we can have mappings. You'll see shortly for the OpenID provider. So the configuration for the OpenID provider, we need to do effectively 2 things. We need to create a new scope. This is so that way we can add additional claims to the ID token, and then we can effectively extract additional information about the user. And this information would actually be provided in a custom attribute. So say, for example, we have a user named Chuck, and we want to map him to an iRODS user. We'd implement a custom attribute and then point him to any iRODS user that we want to map him towards. Yeah, so moving on to the HTTP API configuration, we effectively have just a bit more items that we need to configure, just general information about the host and port, as well as a URI, a well-known URI to extract additional information about the specific OpenID configuration. This is how way the HTTP API knows what endpoints to hit to actually authenticate using the OpenID Connect servers. And we would also need just one other information, which is the client ID. This you just need to also set up in the OpenID provider that you're using. So now we're going to go ahead and step through a basic flow of effectively authenticating using OpenID Connect. So one of the things you need to do is you need to hit the actual HTTP API, the authenticate endpoint of the post request, and you would need to send an authorization header with an iRODS scheme with the base64 encoded username and password. We'll touch a bit more on that later. Just note that this is mostly for demo purposes. From there, the HTTP API would actually extract the username and password, decode it, and extract the information. And then it would effectively convert that information into an appropriate format for the actual token authentication that we do with the OpenID Connect server. You can see an example of that in the middle. And if the authentication was successful and everything runs well, the HTTP API will receive, among other things, an ID token, which is a JWT. And if you're to decode that JSON Web Token, you would then see something akin to this or similar to this. This ID token has all the claims on the user, provides a lot of information on it. For the demo's sake, we only really care about one particular detail. That is the additional information that we created, which is iRODS username attribute or claim. Okay, so with that, we can actually start going into the actual demo itself. So, here we're just going to step through a couple of steps. I'm going to step through a couple of items just to show that it is relatively simple to actually authenticate using the ID Connect endpoint. So here you can see we're going to log in with username of mchuck and password if feels so good, base64 encoded, which then results in that sort of string. We run a curl command to go ahead and post to the authenticate endpoint of the iRODS HTTP API. We also use the specific authorization header mentioned earlier using the iRODS scheme. And there you provide the base64 encoded string. Here's just the verbose output of the curl command. So you can see that it's actually is indeed sending the information in the authorization header. And if everything goes well, you should actually receive a token, which then you could use for further iRODS HTTP API requests. So an example of what we can do with that is take a look at the user's home collection. So in this case, we're going to go ahead and stat the home chuck collection. You can see the curl command for that right there. For the authorization header, we do a bearer scheme and we pass the token that we just retrieved previously in the previous slide. And then we should have the following results. So we're able to authenticate successfully with OAuth and receive a token and then use that token to actually run further, hit further endpoints that require authentication or require you to be authenticated. Right. So on to the challenges faced. Definitely some of the challenges faced was a lot of definitions in OAuth 2.0 and OpenID Connect were pretty confusing for starting out. For example, OAuth 2.0, its definition for client is definitely not what I expected to be, and it took while for me to wrap my head around that. Once I was able to do that, I was able to figure out the specification a lot more faster. Additionally, for OpenID Connect, once I finished reading the OAuth 2.0 spec, I went over to OpenID Connect, the core specification for that. And it was also a bit confusing there as they redefined what OAuth 2.0 defined as a client. They changed it over to relying party, and there's several redefinitions, so I needed to get adjusted to their verbiage. An additional challenge was determining a mapping method. So you saw that in our ID token, the iRODS username claim, that is the mapping method that we chose to go for in the demo, simply because it was relatively easy to implement. But we definitely need to look into alternative methods in the future with some other attributes that I'll show shortly. Additionally, another challenge was actually programmatically determining OpenID Connect endpoints. This one I'm particularly interested in just because it means there's less configuration that needs to be done for the actual client. And as a result, there's less opportunity for error. I'll touch a bit more on that just now, because that will be part of the future considerations. So there are several future considerations for the actual implementation of the OAuth. One of these items would be an alternative mapping mechanism for OAuth users to iRODS. One thing that might be of particular interest here is the OpenID Connect attribute sub, or specifically subject ID. This one is effectively a non-changing attribute that lasts for the entire lifetime of the OpenID Connect user. So using that subject ID to then map to an iRODS user might be of interest if we wish to move to an external mapping mechanism. OAuth credentials handling, we definitely want to reconsider using a custom scheme, in this case an iRODS scheme, an authorization header. We should probably consider some sort of alternative mechanism, possibly sending some information to the body and then deciding the authentication method based off of that. So that's another thing to consider. Additionally, support for more OpenID features. That would definitely be very nice. As previously stated, I really like the automatic discovery, as that means there's less configuration options and you don't need to specify every single endpoint that might be relevant. So that's very nice. Additionally, there's dynamic client registration, which previously just all I need to manually input a client ID. If I understood dynamic client registration correctly, then that might not even need to be done if the OpenID provider that you were to use supports such a feature. Additionally, we need to consider about the possible overlap between the PAM OAuth authentication and the HTTP API, how that would all interact. Some interesting specifications. Although these are draft specifications, we definitely need to keep an eye out for these too. So the OAuth 2.0 security best practices draft actually specifies that the resource owner password credential grant must not be used. Just to reiterate, that is the grant that we use for the demo. So there's definitely something we need to keep an eye out for. Additionally, in the OAuth 2.1 draft, the resource owner password credentials grant was omitted. So the 2.1 draft actually refers to the 2.0 security best practices draft. In that regard, uses the same reasonings, which is there's a potential for increased attack services, as well as implementing two-factor authentication may be difficult or not, or if not impossible, depending on how things are set up in that regard. So definitely some specifications that we need to be looking out for. Yeah. All right. So with all that being said, here's some references to the various RFCs as well as draft specifications in case you might be interested in looking at them. And yeah, thank you for everything. Here's a link to the PR for all of the changes for the HTTP API to actually implement OAuth. If you're curious about that, you can definitely check that out there. Thank you.
All right. All right. Are there any questions? No questions. It is at this point I mean, it may, but it is going to need some polish because we just want to see it work. And so this was kind of like the HTTP API was the sandbox to say, well, can we even do this? Do we understand it enough to make it go? And as you saw, like on the final slide, the grant type that we chose is probably not what people want. So we got to think about that and see how we can incorporate one of the alternatives there. So there's more work to be done, but we proved that we can do it. So yeah.
So by putting HTTP in front, you get the benefit of all of the nerds who have already thought about all this stuff, right? As opposed to in a plugin behind the server, it's basically too late, right? You can't deal with the credentials on the back end in the plugin. So based on what Corey talked about yesterday, this builds on top of that, and I think it opens up a lot of opportunities for getting out of the business of dealing with authentication at the iRODS server level, which I think is the goal.
The DIR simplification. Yeah. I was going to say the DIRS implementation I was going to show later this afternoon is doing essentially that same flow, and it'd be really nice to yank what I have out and place that in there, at least for purposes of demonstrating that. Yeah, because it's the simplest, and that's, yeah. I did it even simpler than was demonstrated there, so this is actually a step up, but it's a demo, so.
Very nice, very nice. Any additional questions? If not, I guess we can prepare for the next speaker.